Hello, statisticians, and welcome to section 9.2. We're going to do a hypothesis test for a population mean where we know the population standard deviation. Just like with confidence intervals, if we know the population standard deviation, we can use the normal distribution. And what we're usually most interested in finding is that p-value, so we can compare it to alpha. To find the p-value, we can say equals norm dot s for standard normal dot dist, open a parentheses, and then our z-value, comma true. And that'll help us find the p-value, but we have to be careful we're in the correct tail, and we'll talk more about that as these examples develop. So it's claimed that the mean price of a gallon of gas is $2.82. We want to show it's less. So if we were to set up our hypotheses for that, we could say that the null hypothesis is that the average is equal to $2.82 as the claim states. We're trying to prove the alternative hypothesis. We want to show that it is less than 282. So as we do that, if we think about our normal distribution, again, it's going to help to draw a picture. The average is 2.82. We're going to try and show that it is less or in this smaller tail. We like it when it's on the left side because that's really how the Excel command is set up. The Excel command will always give us the left side, so we're good to just kind of work through this problem. First, we have to calculate the test statistic. The formula for the test statistics out of the textbook is z equals x bar, or the average from the sample, minus mu, or the average from the hypothesis, close the parentheses, divided by, parentheses for the denominator, sigma, or the standard deviation of the population, divided by SQRT for the square root of the sample size n. And then we'll close the parentheses on the denominator. So if we do that for this situation, we can say equals, open a parentheses, x bar, the 50 gas stations had an average of 277, minus mu, the hypothesis says it's 2.82, divided by, open a parentheses for the denominator, the standard deviation of the population is 0.15, divided by the square root, SQRT, open a parentheses, of the sample size of 50. Close the parentheses on the square root, close the parentheses on the denominator, and we hit enter, and we find our z-value is negative 2.35702. We can now calculate the p-value using that normal command. Equals norm.s.dist, open a parentheses. I'm just going to select our z-value that we just found, comma true, and when we hit enter, we find our p-value is 0.009211, which is smaller than alpha, our level of confidence. If alpha is smaller, we will reject the null hypothesis. Which means we have disproved or proven false this null hypothesis. I'll color it in red because it's been disproven. For our interpretation then, our interpretation basically says we did or did not successfully prove the alternative hypothesis. In context. Here we rejected the null in favor of the alternative, so we did. So we can say there is significant evidence to conclude the average price of a gallon of gas is less than $2.82. That's the alternative hypothesis that we successfully proved. Let's take a look at another example that isn't a left tail test, but it's a different tail. In this next example, it's claimed again that the mean price of a gallon of gas is $2.82, and we want to show that it is more this time. So now our null hypothesis is still that mu is equal to 2.82, but our alternative hypothesis, we're trying to prove that the average is this time greater than 2.82. If we were to draw a picture of this situation, with our average of 2.82, we're trying to show that it's greater or in the right tail, which means we have to be careful with the p-value. We have to find the complement to get the right tail. First, though, we need to calculate our test statistic. We again did a sample of 50 gas stations. This time the average was 284 with the same population known standard deviation of 15 cents. Because we know the population standard deviation, we can use the normal distribution. For our test statistic, using the same formula for z, it's equals, parentheses, the mean of our sample of 2.84 minus the mean of our hypothesis of 2.82, close parentheses, divided by, open a parentheses, the standard deviation is 15, divided by the square root of the sample size of 50. Close the parentheses on the square root, close the parentheses on the denominator. We get a z-value of 0.9428. Now let's calculate the p-value. Be careful with the p-value though, we want a right-tailed test. A right-tailed test means we have to use the complement of the left side. So we're going to say equals 1 minus, which will give us the right tail, norm.s.dist, open a parentheses, select the test statistic, comma true, and when we hit enter, we find that our p-value is 0.17289. This is much larger than the alpha. So we don't have enough evidence to reject the null, so we have failed to reject the null. So we could not reject the null hypothesis, so we're kind of stuck with it. And I'm going to color it not green, but I'm going to color it yellow. The reason I don't want to color it green is we never actually prove the null hypothesis. We just failed to reject it. So when we get to our interpretation basically says every time there is or there is enough evidence to prove the alternative hypothesis in context. So because we failed to reject, we're going to say there is not significant evidence to conclude the average price of a gallon of gas is, as the alternate says, greater than $2.82. Again, notice we're focusing on the alternative when we write our interpretation. Let's do one last example. This last example is going to be a two-tailed test. Again, we're going to have the claim that the gallon of gas is 282. We just want to show that it's different than 282. We don't care if it's greater than or less than. In this case, the null hypothesis is still that mu is 282. The alternative hypothesis is that mu is not 282. Which means if I were to draw a picture of this distribution, we don't care if it's smaller or larger. Which means we're going to have to find out how much area is in one tail, and then we're going to have to double it to get the full two-tail area. First, though, our test statistic. If we look this time, it says the average price of our 50 gas stations is $2.85 this time. So it's going to be, open a parentheses, $2.85 minus the mean of $2.82, close the parentheses, divided by, open a parentheses. The standard deviation is still 0.15, divided by the square root of the sample size, which is 50. Close the parentheses on the square root, close the parentheses on the denominator, and our test statistic is 1.41. Notice that 1.41 is positive, which means it is the right tail. If it was negative, it would be the left tail. So we have to treat this p-value like it is the right tail. So we're going to say equals 1 minus the norm.s.dist, open a parentheses, our z-value, comma true. And I'm going to hit tab instead of enter because that's going to move me over. The problem with this p-value is that p-value is just the right tail. To get both tails, we have to double it. So I'm going to say equals 2 times the p-value, or the right tail. And that's going to give me a total area in the tails, a final two-tailed p-value of 0.157299. which again is larger than our alpha, so our decision is to fail to reject the null hypothesis. So again, we failed at our goal, so we're going to say there is not significant evidence to conclude the average price of a gallon of gas is, this time the alternative says not $2.82. We did a few more examples this time just to get really good at practicing the hypothesis test process. Also to see how things are slightly different if it's a right tail, left tail, or two-tailed test. And you have to make sure you're accounting for that with your p-value. Good luck on your assignment.